Find the square roots of I. Oh my gosh. First off, I hope that's enough room. To be able to do this, we need to write I into trigonometric form, because when it's just I, it's in standard form. So we're going to bypass that whole ABR thing. We're just going to do this. I is the same thing as 0 plus 1I, so what ordered pair would that be? Zero, 1. So how far is that point from the origin? 1. What angle would be needed to make that ordered pair? 90 degrees. So our R is 1, our theta is 90 degrees. So the complex number I in trigonometric form is 1 cosine of 90 degrees sine it plus I sine of 90 degrees. Our R being 1 is sort of boring because the roots of 1 are still just 1, so we're not going to see too much there. But by saying square roots of I, what's n? Careful. 2. Very good. So let's set up this tasty, tasty formula. Here it comes. We're going to have 1 to the 1 over 2 cosine of your angle theta divided by n. In our case, it's 2. Plus k times 360 divided by n, which is also 2. And we're just going to repeat that for the sine. So our theta is 90 degrees, our n is 2, k is just k. Let's clean up the arguments. What is 90 over 2? And what's 360 over 2? All right, so now we start plugging in numbers in for k. You always start when k equals 0. So let's put in 0 in for k. If k was 0, what's the argument of our sine and cosine functions? 45. Does everyone see that? Because 0 times 180 is 0, plus 45 is 45. So we're working with 1 to the 1 half, cosine of 45 degrees plus I sine of 45 degrees. What is the well, first off, what is 1 to the 1 half? Careful. It's not an equation. It's not x squared equals 1. That's where you would say plus or minus 1. It's just 1 to the 1 half, which means the square root of 1 is just 1. When you take a square root of an equation, you include a plus or minus. But if I say square root of 25, you don't say plus or minus 25. Is that okay? When you take a square root of an equation, you include a plus or minus. So what's the square root of 49? No. When we just say square root of a number, we're talking about the primary square root, the positive, not negative one, I should say. Yeah. But if I said x squared equals 49, then you would say x is plus or minus 7. It's only when an equation is involved. Ding, ding, ding. That's high leadership. All right, 1 to the 1/2 is 1, so we don't have to write it anymore because we're just going to multiply by 1. But what is the cosine of 45 degrees? And same for the sine. Very good. We have found 1 square root of I, meaning that if we squared radical 2 over 2 plus I times square root 2 over 2, we would get I. That's what it means to be a square root. 3 is the square root of 9 because 3 squared is 9. Radical 2 over 2 plus I square root of 2 over 2 is a square root of I because its squared is I. Yay, but we're not done. How many square roots should we have? Those. So we stop at n minus 1. So if n was 2, 2 minus 1 is 1. So what's our next number for k? Same answer, 1. So now we put in 1 in for k. So if k were 1, what's 45 degrees plus k times 180? 225. So we're going to have 1 to the 1/2 cosine of 225 degrees plus I sine 225 degrees. KFL, much better Spanish than most presidential candidates. What is the cosine of 225 degrees? Negative radical 2 over 2. And the sine? Yep, and again, we're going to ignore the 1 to the 1/2 because that's also just 1. So negative radical 2 over 2 minus 1 over 1 radical 2 over 2 is the other square root of I. So if you square the numbers in the boxes, you would get I. Right, because if we now put in k to be 2, then we're just going to add 360. That angle created would just be coterminal to 45, which means we would just get the same answer. Okay? So we don't need to keep going after this. Good. All right, so the other way they can ask this question is solve for x, and they say x squared equals I. And then to solve for x, you'd have to take the square roots of I. So they might present it to you in an equation format, or they might say it in a sentence format. It means the exact same thing. There is that. Fun fact, if we were to graph this, radical 2 over 2, comma, radical 2 over 2, we should know that's, as we found, a 45-degree angle somewhere. The distance from the origin is 1. That's what the R means. And negative radical 2 over 2, negative radical 2 over 2 is on the other side of it. What's the angle between them? 180. So the reason, as I said earlier, we can sort of ignore this k 360 over n thing because you just keep adding whatever 360 over n is. So if we were doing a fourth root, 360 over n would be 90 degrees. 90 degrees. So we're going to, whatever angle we start with, to get the next angle, you just keep adding 90 degrees until you get all 4 angles accounted for. Is that okay? All right. So even though the formula looks horrendous, you just keep adding the same angle over and over again. When you plot them, they should make a geometric figure. 2 square roots, not so nice. They should be right from across from each other, so they don't really make anything special. But if you had cube roots, they should form an equilateral triangle. Fourth root should form a square. Fifth root should form a pentagon, things like that. So that way you know you did it right